Alright, so now we've learned about ions, so our next step in our journey is talking about ionic compounds. So ionic compounds obviously are made from ions, hence the term ionic compounds. So they're made when you have elements that gain or lose electrons to form ions, and then they're put together. Now, keep in mind though that these are neutral compounds though, because the positives and the negatives cancel each other out. They are always a combination of a metal with a non-metal. So this is really important. This is why we had to learn what a metal is and what a non-metal is. Because if you don't know what a metal is and what a non-metal is, you won't be able to identify, hey, is this ionic or is this a covalent compound? Ionic compounds I refer to as types 1s and 2s as far as writing formulas. So that might help you. It's just a little easier way to classify, okay? Now, here are the basic steps. Running through this might be confusing, but if you need to go back and say, hey, okay, what's my step by step? So, first of all, step 1, look at it. This will be a metal with a non-metal, okay? Step 2 will be write the symbol of the element or polyatomic. Again, that'll make more sense as we go along. With the positive charge first in the name. A polyatomic ion, here's just kind of a definition for later. Polyatomic ions are just ions that contain more than one atom. We'll look at those a little later, step by step, right? Write the symbol of the element or polyatomic ion then with the negative charge. So it always goes positive, then negative. So just remember that in your process, positive and negative. Then you cross the charges and you reduce if you can. Those are just kind of some steps. Again, I'm going through this fast, but I think it works out better if we just get some examples going, okay? So, but if you need to come back, here you go. All right. Okay, so here are 2 examples we'll run through, okay? So, like I said, you need to start, good practice, is looking at the first element and saying, okay, is that a metal or a non-metal? Well, sodium lies on the left-hand side of the periodic table, so you'll need your periodic tables for this, obviously. So it lies on the left-hand side, so it's a metal. So as soon as you identify that it's a metal, you know it's going to be a type 1 or type 2. Because type 1s or type 2s, okay, they start with metals. So that's just some helpful, So all of these should start with metals, but again, start asking yourself these questions because remember, by the end of this entire process, you're going to have every type of compound thrown together. So you have to start asking yourself the questions now with the easy ones so that when you get all of them thrown together, you're like, what do I do? So, starts with a metal. Okay? Then you say, okay, sodium. Do I know the charge of sodium? Well, yeah, it's in that first column. I know that sodium, I'm just going to go ahead and write it down. Sodium's in that first column. It always makes a 1 plus. 1s, you know the charge of. Meaning like, is it 1 plus 2 plus 3 plus whatever? Okay? So 1 plus 2 plus 3 plus none, 3 minus 2 minus 1 minus none. Okay? So you know the charge. So sodium, yes, I know the charge. Oxide. Now, oxide, you'll learn later that all we did is take the ending off of oxygen and changed it to "ide." So this is just oxygen, which I will always know the charge of the second element, so I never have to ask myself that question. So oxygen is O, and I'll look that up on the periodic table, and that's a 2 minus. Now, a lot of old school, and even in my notes that I had earlier, it said to check and see if you could reduce after you cross. I always like to look and see if I can reduce first, meaning that I have a 1 and a 2. Are those divisible by any whole number? The answer is no, right? I can divide it by 1, but what good does that do? So now, all you're going to do is you're going to take this 1, and you're going to put it down here, and you're going to take this 2 and put it down there. It's called the cross method. So you have Na with a 2, and then you have an O with a 1. Now, one thing you have to start learning about chemists is that we do not like 1s. We don't like to write 1s in our formulas. It's just extra stuff we don't have to write. So, This, even though it's crossed correctly, is not written correctly. We actually write it as just Na2O. And that's the correct answer. Okay. All right, here we go. Let's try another one here. Again, calcium. Calcium is a metal. It lies to the left-hand side. It's in group 2A, so actually calcium is in group 2A, so that means it's a 2+. I gave you oxygen again, just to keep it simple. Oxygen, 2-. Because again, oxide, just, the ending came off, oxygen. Now, here's a good example of what I was talking about a minute ago. Look, both these are 2's. That's divisible by 2. So that's actually, I could change that to a 1+, and that to a 1-. So I'm crossing 1's. So that's actually the formula of Ca1O1. But again, we don't like 1, so the correct formula would just be CaO. And so there's your type 1s.